This is Chapter 7, and we're going to be looking at determining molecular formulas. So here's the steps to solve molecular formula problems. In this case, you're going to be given some experimental data, and from that you have to determine the molecular formula. So here are your steps. First, you have to determine the empirical formula, and remember, empirical means the reduced, so it is the lowest whole number ratio. And then once you figure out the empirical formula, you're going to determine the empirical mass, and you're going to do it just like a molar mass using the periodic table. After that, you're going to take your molecular mass, that's your molar mass, divide it by your empirical mass, and this will be a formula multiplier. So you're going to multiply all the empirical formula subscripts by the multiplier that you figure out up here. So let's work a few examples. The empirical formula of a compound is NO2. Its molecular mass is 92 grams per mole. What is its molecular formula? Well, in this case, we've been given the empirical formula already, but we still need to figure out its empirical mass. So we're going to figure out its empirical mass. So let's abbreviate this. Empirical, EMP mass, is going to be 14.01 plus 2 times 16.00. So just plug that into your calculator. And you'll see that that turns out to be 46.01 grams. And that's for NO2. So it's NO2's empirical mass. Now, the molecular mass is 92 grams. So we have to figure out how many times NO2 fits into the molecule. So we're going to take 92 grams and we're going to divide it by the 46.01 grams. And once you do that, you get a value of 2.0 to nearest significant figures. This is your multiplier. So what you're going to take is you're going to take this 2 and you're going to multiply the subscripts by this. So this becomes N2O4. You took your multiplier, 2, and you multiplied it by the nitrogen, and then you took 2 times 2 for the oxygen. So double check if you have N2O4, is NO2 the empirical formula? And yes, it is. Let's do another one. The empirical formula of a compound is CH. Its molecular mass is 65.09 grams per mole. What is the compound's molecular formula? So I want you to give this a try. I'm going to put down the answer for you, and I want you to see if you get there. There's your answer. See if you get there. Your first step is you should have calculated the empirical mass as being 13.018 grams. Then you're going to take your molecular mass, 65.09, divide it by the 13.018, and you get 5. So you have 5 CHs, which means you've got C5H5. Let's go down to the next problem. This is the next problem, and this one is definitely more complicated. We have a compound that is 40% carbon, 6.7% hydrogen, and 53.5% oxygen. Its molecular mass is 60.0 grams per mole. What is the molecular formula? So the first thing that you are going to have to do is you're going to have to figure out the empirical formula, just like we did when we were looking at empirical formulas earlier. So what this means is you're going to have to convert 40% carbon to 40 grams of carbon. This is going to be 6.7 grams of hydrogen, and this is going to be 53.5 grams of oxygen, and you're going to find the moles of each one. So we have 40.0 grams of carbon. We're going to come down a little bit. We're going to say that we have 6.7 grams of hydrogen. Down a little more. We have 53.5 grams of oxygen. And we're going to convert each to moles. So we look on the periodic table, and we have 12.01 grams of carbon for every 1 mole of carbon. We have 1.008 grams of hydrogen for every 1 mole of hydrogen. And we have 16.00 grams of oxygen for every 1 mole of oxygen. If you plug these into your calculator, you'll get the moles of each element. So we have 3.33 moles of carbon. We have 6.6 moles of hydrogen, and we have 3.34 moles of oxygen. We're going to take all of these and we're going to convert them into subscripts. So we have carbon, 3.33, hydrogen, 6.6, oxygen, 3.34. So we have 3.33 carbons for every 6.6 hydrogens for every 3.34 oxygens. We need to get these into whole numbers. We're going to divide by the smallest. And carbon has the least number in the subscript, so we're going to divide everything through by 3.33. So our formula ends up being C1H2O1, which we'll rewrite as CH2O. We're not done yet, though. This is our empirical formula. However, we're trying to find our molecular formula. So what we have right here is our empirical formula. You're done with the hard part, actually. Now, we're going to do the molecular formula. So, we need to figure out the mass of CH2O. So, mass CH2O is 12.01 plus 2 times 1.008 plus 16.00 for a total of 30.026 grams. Now remember, this is your empirical mass only. So we need to figure out how many times does this fit in to 60.0 grams per mole. So we're going to take our molecular mass, and we're going to divide it by the empirical mass. So we have 60.0 divided by 30.026. That's going to be 2. So we're going to take this 2 here, and we're going to multiply all the subscripts in this empirical formula by that 2. So we're going to get C2H4O2. Put a box around it, you are all done. And that is the end of empirical formulas.